A couple days ago, my youngest son got an ear infection and needed an antibiotic. And I found myself sitting at my dining room table with my 3 kids, pulling out a piece of pink construction paper out of our craft cupboard, scribbling a whole bunch of med math all over it to try to figure out if my son's dose of antibiotic was appropriate. As I was doing that, I had this sudden realization that, hey, this is the perfect example of an equation from real life that I could share with my students. So that's what I'm going to do today. In this video, I'm going to talk to you about dimensional analysis and how it's the one approach to all med math that you'll ever need. I'm going to show you how to use it on 5 different equations from simple to more complex. We will end with this particular thing from my son's amoxicillin prescription. And by the end of it, you'll be able to protect your patients from overdosing or having toxicity from too high of a dose, as well as ineffective sub-therapeutic low doses. So let's just get at it. The first thing we're going to do is just a simple conversion from kilograms to pounds. It's a unit conversion. There's a whole bunch of units that we can convert, and I've made a PDF of all the different kind of conversions. A lot of these are worth memorizing, especially pounds to kilograms and vice versa, but also liters to milliliters. That should be easy, but the teaspoons, tablespoons to mLs, those are worth knowing. But I have this here for your reference, and what I want to do is just convert my son's weight in pounds over to kilograms using dimensional analysis because it's a very easy one to start with. So let's go ahead and get at it. If you'll notice here, 1 kilogram is equivalent to 2.2 pounds. Got to remember that. So my son weighs 18 pounds. If I needed to know his weight in kilograms, the way I will use dimensional analysis is by starting with the unit that I want to figure out, okay? I know how many pounds he weighs, but I want to know what he weighs in kilograms. And so you start a math equation and you start with the unit you're hoping to find, and you write that down on the left side of the equation. So kilograms equals, now the second step is to find a way to put this unit on the top of the first ratio that you place on the right side of the equation. So how can I get kilograms here? I can't use my given information of 18 pounds because that's pounds, not kilograms. But what I can do is know my conversion factor. Remember from our PDF over here, 1 kilogram is the same as 2.2 pounds. So let's write this here. 1 kilogram is the same as 2.2 pounds. All right, so now I have kilograms on the left side of my equation. That's what I'm solving for, but I also have it on the top of my first ratio. But now I need to get rid of pounds here. And the way that I can do that is by cross-multiplying and adding a second ratio over here. I have pounds here. I need to put it over here. So what I'm going to do is add my son's weight in pounds down here, and this will say 18 pounds. Now at this point, my units can cross out here because the pounds will cross multiply, and now I just need to do the math. So 1 times 18 over 2.2. And then kilograms will come down here too. So that's 18 kilograms divided by 2.2, which if we do our math real quick, let me pull up my calculator. 18 divided by 2.2 equals 8.18 kilograms. So my 18-pound son weighs about 8 kilograms. That's a simple example. All right, so now let's move to something a little more complicated. We're going to move on to actual med math. So the first thing we'll do is actually work with an order for a pill. So let's say you are given an order for a certain dose of a medication, but the available pills dosages don't match the order that's given. Sometimes you have to figure out how many pills to give. So let's say you have an order for metoprolol, 37.5 milligrams by mouth, but the only thing available are 25 milligram tablets. How can you use dimensional analysis to figure this out? Let's do it. How many tablets do we give if we have an order for 37.5? So we use dimensional analysis. So what's step 1? Write on the left side of the equation the unit you are trying to solve for. I want to know how many tablets I give. So tabs equals. Step 2 is to put this unit in the first top portion of that first ratio. So how can I put tablets on top? Well, I know I have 25 milligrams per tablet, so I'm going to say 1 tablet is equivalent to 25 milligrams. Now I need to cross out milligrams. This one right here, I need to get rid of this one. So how can I put milligrams up here? I know I have an order for 37.5 milligrams. And that crosses out milligrams on both sides, and I am left only with tablets. So now I just need to do my math. So that's 1 times 37.5 tablets over 25. And if we just do our math on that there, I believe that's going to be 1.5, but let's just take a look, huh? 37.5 divided by 25 is 1.5 tablets. So this patient needs a tablet and a half of metoprolol to get to the ordered dose. Not that complicated, right? Let's keep moving on. Let's go to an IV medication now. So let's say we have an order for an IV antibiotic, ceftriaxone, and we need to figure out how many milliliters per hour to program the pump to. Okay, so we have an order for ceftriaxone 500 milligrams. That's our order. So what we have is a bag of ceftriaxone that has 500 milligrams of ceftriaxone in 55, whoa, that's a weird 55 milliliters of fluid. All right, so what's our step 1 here? Look for the units you are trying to figure out. So what do I need to know? mLs per hour. So I'm just going to write on the left side of the equation, mLs per hour equals. So I'm solving for mLs per hour. How do I put mLs on the top of the first ratio? Let's go here. I'm actually going to write ml, and I'm just going to look for something. Well, I know I have 500 milligrams per 55 mLs, so let's do 55 mLs is equivalent to 500 milligrams of ceftriaxone. Now I need to cancel out my milligrams, so I'm going to go over here and add milligrams. I need to find something else. I have an order for 500 milligrams of ceftriaxone. So 500 milligrams of ceftriaxone over 30 minutes, because that's what's written here. So I've gotten rid of milligrams, but now I have minutes, and I'm looking for hours. So how can I convert minutes to hours? Well, I know that one in my head. I hope you do too, that there are 60 minutes in 1 hour. And now my minutes are gone, and if all I have left is mLs per hour. So let's do our math. We have 55 times 500 times 60 over 500 times 30. Now you could do this math, or if you want, you could cross out this 500 and this 500, so we can get rid of this and this, and that gives us 55 times 60 over 30. And you could simplify that even more, but this is not a math lesson. This is kind of is, isn't it? Let's do 55 times 60 equals divided by 30 equals, and we get 110, what is it? mLs per hour. Now, whenever you finish an equation with dimensional analysis, at the end you need to kind of ask yourself, in common sense, does this answer make sense? Like, should I have a rate of 110 mLs per hour? Yes, that's kind of a standard rate for an IV. If it said run it at 7,000 mLs per hour, maybe it's not right. Okay, or if it said run it at 1 milliliter per hour, maybe it's not right. But yes, this is correct. And again, our dimensional analysis has saved the day. Okay, let's make this one step more complicated. Let's say you're working in the ER and you have an order to run IV saline, but all you have is a gravity drip. You don't have a pump for your IV, and so you need to actually count the number of drops. So let's do that. All right, so the order says 1 liter of saline over 8 hours. When you look at your IV tubing, you know that the drip factor is 15 drops per ml. That's just something that's going to be labeled on the tubing itself. All right, so in this case, if I'm working in the ER, I don't need it in milliliters per hour because I'm not going to have a pump, right? I'm doing a gravity drip, so what do I need? I need drops per minute because that's what I can actually count when I hang my IV. So dimensional analysis, what's the first thing I do? I put my desired units on the left side of the equation. So I need drops per minute, and I don't know why GTT means drops, probably some Latin thing, but regardless, that's what it means. And what's step 2? Put these units on the top of the first ratio. Drops. Okay. How can I fill this in? So I know I have 15 drops per ml on my IV tubing, so for 1 ml. Now, how can I get rid of my mLs? Well, I have an order for liters. Now, that's obviously not the same thing as a milliliter, but I do know how to convert those. And so since I need mLs on top for cross multiplication, I know that 1 liter has 1,000 milliliters. So now my mLs have crossed out, and that was just me having my conversions memorized. Now I need to get rid of liters. Well, I have an order for 1 liter over 8 hours, so I'm literally going to type 1 liter over 8 hours. And that gets rid of my liters, but I am looking for drops per minute, and so I need to cancel my hours by converting my hours into minutes. I know that 1 hour is equivalent to 60 minutes, and now my hours have canceled, and all that I have left is drops per minute, which is indeed what I am looking for, so let's just do the math. We have 15 times 1,000 times 1 times 1 over 1 times 1 times 8 times 60. So that is 15 times 1,000 equals 15,000. That I really should have known that. It's crazy. And then 8 times 60 is 480. So that equals 15,000 divided by 480 is 31.25 drops per minute. Now with drops, you're always going to round to the nearest because you can't count a 0.25 drop in reality, so that would round down to 31 drops per minute. All right, so for this one, we're going to use the prescription that I mentioned at the beginning of the video of my son's actual script for amoxicillin. This is going to be an example of dosing pediatric antibiotics and making sure that they're at a safe range. So in this situation, like I had said before, my son is 18 pounds, at least at the time that I'm recording this. So we have an 18-pound patient. The order for amoxicillin for an ear infection is to be given 90 milligrams of medication per kilogram of body weight per day. However, it's to be dosed twice a day. So this is PO, BID. PO is by mouth, BID is bi-daily or twice daily. So that's something that we know. Now, if you look on the bottle, you'll see that the concentration says 400 milligrams per 5 ml. So in this case, I was wanting to verify how many milliliters of fluid in each dose that I should be giving to my son. So first thing in dimensional analysis is write down the units you are looking for, right? So I am looking for mLs per dose. Step 2, put that top unit on the first ratio on the top, right? So how can I put mLs up here? Well, I know I have 5 mLs per 400 milligrams. That's just the concentration. So 5 mLs per 400 milligrams of amoxicillin. How can I cancel out milligrams? Let's put this up here. I know I have an order for 90 milligrams per kilogram per day, or mgs per kg per day is a more fun way to say it. So I have 90 milligrams. Now, whenever you have something written like this, the first unit, so milligrams, moves to the top of the ratio, while the bottom two move together to the bottom. And so we here would have over kilogram per day. This is an X. Okay, so these, because they're both moving over to the bottom of the fraction, this divided by sign turns into a multiplied sign. So that's how you move megs per kg per day into a fraction like this. All right, so my milligrams are canceled out. Now I need to cancel kilograms. How can I do that? A lot of arrows here. Well, I'm going to multiply and see if I can put kilograms up here. What other information do I have? I know that my son is 18 pounds, but that's not kilograms, so I'm going to have to convert to kilograms. So how many kilograms are in a pound? If we don't remember, go back to our handy-dandy chart. 1 kilogram is 2.2 pounds. So 1 kilogram is 2.2 pounds. So I have canceled out kilograms, but now I need pounds. I remember my son is 18 pounds. You can just put something over 1 if it doesn't have anything to go with it, like in this case. So now I've canceled my pounds. Now I still have days, and I'm looking for doses, so I need to think, how can I combine those two? Well, I know it's ordered BID, or 2 doses per day, so for 1 day, I can say 2 doses. And that should cancel out days and days. And let's take a look. I have mLs per dose, and no other units are remaining, and that matches my mLs per dose. So let's do the math. So we have 5 times 90 times 18, if I take out the ones, over 400 times 2.2 times 2. Let's pull up our calculator. 5 times 90 times 18 equals 8,100. 8,100 over 400 times 2.2 times 2 is 1760. And then let's do our dividing. 1800 divided by 1760 is 4.6 mLs per dose. And I believe it got rounded to 4.5. Let's take a look and see. Again, I'm going to hide all of his information here. Yes. Give 4.5 mLs twice daily. All right. All right. That is the glory of dimensional analysis. Again, I gave you 5 different kinds of examples here of med math problems, simple conversions, IV drip rates, pediatric dosing. I'm going to give you guys in the description a link to a PDF of like more med math questions you can work through if you want to. I'll include some answers and the rationale of how to get there. But it's not that complicated. So use dimensional analysis. Like I said, it's very helpful in high stress situations. I have used dimensional analysis both on my children, like you've seen, literally, and also in the hospital when I've been in a stressful situation to verify some heparin dosing or things like that. I love that if you're stressed and a little frazzled, it can keep you grounded by just canceling out units. You don't have to remember an equation or anything like that. Very simple. As long as you have a calculator, you can do it. If there's anything I could further clarify, or if you have any questions or anything else you want me to go into in more detail, please leave that in the comments and I'll see what I can do for you. Have a good evening.